Welcome back, everybody. We are now going to talk about the second half of independent samples t-test. This is chapter 14. We've already discussed how to calculate an independent samples t-test, but now I need to give you the second half because it's not that easy. So we looked at this formula last time when we were talking about independent samples t-test. However, this formula only works if n sub 1 equals n sub 2. That means if the two samples that you're talking about have the same number of people in it. That only works if they're equal. If they're not equal, then we have to do something a little bit different because what we have down here, remember s squared, that's the variance. So the variance of group 1 versus the variance of group 2 divided by the number of people in group 1 compared to the number of people in group 2. That's what these are looking at. Now, if we have different numbers of people, then the best thing that we can do is actually what's called pooling the variance. We actually, instead of taking just the variance of one compared to just the variance of the other, we pool the variances together to get one number. And so let me show you what it looks like. If n sub 1 does not equal n sub 2, that is, if the two different groups have different numbers of people in them, then what you should actually do is pool the variance. This down here, s squared sub p, which you see in both of them now, that's called the pooled variance. So instead of using the strict variance of one group versus the strict variance of the other, the normal variance, we're now getting the pooled variance. So this is what we've got. So this is the new formula for t, but we've got to calculate s sub p, s squared sub p, which is the pooled variance. And to get the pooled variance, we need to go through this formula right here. What we're doing is we're taking n sub 1 minus 1, so the number of people in the first group minus 1, times the variance of that group. Now, n sub 1 minus 1, you think of that like the degrees of freedom for that group. So the degrees of freedom times the variance plus the degrees of freedom times the variance of the other group, which is right here, n sub 2 minus 1 times the variance. You divide that by the variance of everything. In fact, if you remember, n sub 1 plus n sub 2 minus 2, that's the degrees of freedom formula that we use for all of independent samples t-test. This is the degrees of freedom. So what we're doing is we're taking the variance of each group times their individual degrees of freedom, adding that together, dividing by all the degrees of freedom to get that number. So we'll get to these in just a second, but this is what we're looking at right now. So here's what I want you to do. I want you to calculate the pooled variance and t for the data that we used last time. So this is the data that we used last time in terms of psychology majors versus business majors, right? X bar sub 1 is 6, X bar sub 2 is 5. X bar sub 1 in this particular case is going to be psychology versus business is sub 2. So calculate the pooled variance and then calculate T. If you've done it right, it should end up being the same as when we calculated with the original one, because in this particular case, n sub 1 does equal n sub 2. You'll end up with the same thing. However, when n sub 1 and n sub 2 are not the same, we'll get something else. But let's start with something that is the same first. All right, to do this, let's go ahead and look at how to calculate these data. Here is the data from the original time that we looked at this. You remember? Here's the original data right here. Okay. And then we separated it. This is all for psychology. And then we'll move this over a little bit. This is all for business majors. So that's when we separated it out. When we use the old formula, this is the old formula. This is what we got. And the t equaled 0.447, right? Now what we're going to do is we're going to, instead of using this formula right here, we're using this formula right here, which looks almost exactly the same, except now that we're looking for that pooled variance. And to get the pooled variance, we're going to use this particular formula right here. So the first thing we need to do is figure out what is the pooled variance for these data. Remember, sub 1, that's psychology, right? Sub 2, this part over here, that's going to be business. So n sub 1 is the n for psychology majors, the number of psychology majors we have. That's going to be 2. And then we know that this S squared sub 1, that is the variance of psychology majors. The sub 1 is psychology majors. S squared, that is the standard deviation squared. That is the variance right there. So what this part is saying right here, n sub 1 minus 1 is 2, n sub 1, minus 1 equals 1, times the variance. So all we're looking for here is 1 times 8. So this whole thing, n sub 1 minus 1 times s sub 1 squared, that's 8. Over here we have n sub 2. In this case, it's also 2. Minus 1 is 1 times the variance of business majors. And the variance of business majors is over here. It is right there, 2. That is the variance for the business majors. So when you look at that, this second portion right here, n sub 2 minus 1 equals 1 times the variance of business majors, which is 2. So this is 2 times 1. That equals 2. Okay, 2 times 1 equals 2. So this part right here, that's 8 plus 2. 8 plus 2 equals 10. So the numerator in this particular case, this whole thing is going to be 10. We need to divide 10 by n sub 1. N sub 1 is 2, plus n sub 2, which is also 2, minus 2. 2 plus 2 is 4, minus 2 is 2. So the the denominator is going to be 2. That means that our pooled variance again is S sub p squared. That's what this is. Pooled variance, that's S sub p squared, that's what that is going to be 10 divided by 2. So it is 10, you already know what this is, divided by 2, and you get 5. So the pooled variance is 5. So now when we calculate the t, instead of using the variance for the individual groups, we're going to use that pooled variance. We're going to use 5. It's going to be the same for both of those terms. It's going to be 5. Okay? So we've already calculated some of this. If you remember over here, this is x bar sub 1 minus x bar sub 2. So x bar sub 1, that is the mean of psychology, that's 6, minus x bar sub 2, that's the mean for business major, that's 5. So 6 minus 5 is 1. Now, we got to take now our pooled variance and divide each of these by the pooled variance. Now, lucky for us, we know what the pooled variance is now. We just calculated it. It's right there. It's 5. Okay, so the pooled variance is going to be 5. 5 divided by 2 plus 5 divided by 2. Guess what? When you divide 5 by 2 plus 5 divided by 2, you're going to get 5. So what we need, just to know what we're talking about, the pooled variance here is 5 divided by n sub 1, which is 2. So that's going to be 2.5, plus the pooled variance 5 divided by n sub 2, which is 2. That's 2.5. 2.5 plus 2.5 equals 5. So right here, we're going to get this. We need to get the square root of that. So we need the square root of 5. And that is 0.23607. Now, the reason why that's the same is because those denominators are the same. We had square root of 5 over here. We have square root of 5 here. The reason why is because when we use the old formula, we also got 2.23607 because we got it in a different way. When n is the same, you're going to end up with that same thing, and then you get the square root and it works out the same. The square roots these are going to end up being the same for sure, but now we're going to do it in a pooled manner instead. All right, so when you do that, and then you take 1 divided by the square root of 5, you're going to get this t 0.447. It is the same thing. So the pooled variance was 5, and t is going to be the same as it was with the old formula, 0.447. Now, let's use one that actually does have different n. So here's some data, and here's my hypothesis. My hypothesis is that people who love cats more than dogs are going to drink more tea, right? So I've got cat people, I've got dog people, and then I measured here how much tea they drank. Cat people, dog people, and then how much tea they drank. So for example, person 1 is a cat person and drank 2 cups of tea. Person 2 is a dog person, drank 3 cups of tea. That's what this says. All right, so now what we're going to do is we're going to look at this using the new data. So what I want you to do is I want you to calculate the pooled variance and t for these new data. And if you notice, we have a different n for each group now. We have a different number of cat people than we have of dog people. So you have to create the pooled variance instead of just using the variance of each individual group. Okay, so to do this, let's go ahead and begin with the same information we had before. So here's all the information that I just gave you. So each of the people, their preference for cat or dog, and how many cups of tea they drank. Then I've separated these out. So these are all the people who love cats more and the number of cups of tea they drank. So 2 cups of tea, 5 cups of tea, 6 cups of tea, et cetera, et cetera, et cetera. And these are all the dog people and how many cups of tea they drank. Now, you will notice that we have 1, 2, 3, 4, 5, 6, 7 people who prefer dogs. And that is why right here we have n equals 7. Versus over here, we have 1, 2, 3, 4, 5, 6. So we have an n of 6. 6 people prefer dog, or excuse me, 6 people prefer cats, and 7 people prefer dogs. So I've already gone through and I've calculated the variance for you for each of these. So the variance for cat people is here. The variance for dog people is here, right here. So now what we need to do is we need to create the pooled variance. So if you remember, the way we do the pooled variance is we take n sub 1, so sub 1 will be cat people for us. So n sub 1 minus 1, so n sub 1 is 6, minus 1 is 5, times the variance of the first group, variance sub 1. Okay, so in order to do that, then we need that first term. So we need n sub 1, which is 6, minus 1, right, times variance sub 1, variance of the first group. So this is going to be 9.5. We need to do the same thing then for the other group. So in this particular case, I'm going to need n sub 1, which is 7, minus 1 times the variance, whoops, right there, times the variance of that group. So that's the variance for the dog people, which is 5.71, etc. When you add those together, we get the numerator equals this plus this. This is the numerator of the formula. So if you remember when we looked at the formula, we wanted to get, and I'll show you again on these slides right here, we wanted to get the pooled variance, which is n sub 1 minus 1 times the variance of that group, plus n sub 2 minus 1 times the variance of the second group. So this is the numerator right here. That is the same information that we just barely calculated right here. So this is the numerator right there. We need to divide that by the degrees of freedom. The degrees of freedom is going to be n sub 1 plus n sub 2 minus 2. So we need 6 plus 7 minus 2. So I'll just do the formula because it sounds like fun. Equals 6 plus 7 minus 2. Guess what? You get 11. When you divide that, that's going to give us our pooled variance. So our pooled variance is going to be this number divided by the degrees of freedom, that number right there, 1.383. 1.3117. This is our pooled variance. So now what we're going to do is, instead of using the individual variances when we calculate t, we're going to use the pooled variance instead. So if you remember, we're looking at x bar sub 1 minus x bar sub 2 divided by the square root of the pooled variance divided by n sub 1 plus the pooled variance of n sub divided by n sub 2, and take the square root of that whole thing. Okay? And this is going to give us our t statistic. Now, that means that we need to get x bar sub 1 minus x bar sub 2. So let's go ahead and get that numerator going over here. Let me move this over a little bit just to give us some space. So the numerator is going to be x bar sub 1 minus x bar sub 2. So that is the mean of the cat people minus the mean of the dog people. Okay, remember we're talking about cups of tea. So average cups of tea for cat people, 4.5. Average cups of tea for dog people, 1.42. When you subtract that, that's what you get. That's the numerator. Now, this is going to be a little bit more complicated when we talk about the denominator, because now what we have to do is we have to take this pooled variance divided by the individual n's. So 1.38 divided by 6 plus 1.38 divided by 7. And then we have to take the square root of that whole thing. So let's get each one of these separately. So we need to get, let's start with the cat people. So first we're going to get pooled variance divided by n sub 1. That's what that is right there. So the pooled variance divided by n sub 1. The first group is the cat people. And we get this number right there. The second one is the pooled variance divided by n sub 2. That's the dog people right there. We get that number right there. We add those together. And we get this number right here. Now that's not the denominator yet. This is what we need to get the square root of. So we need the square root of that number. And we get this number right here, 0.654. This is the denominator. Okay? So let's go ahead and calculate our t using pooled variance. So t is going to equal the numerator divided by the denominator. Now remember, this numerator is x bar sub 1 minus x bar sub 2. So 4.5 minus 1.42857 divided by pooled variance divided by n sub 1, pooled variance divided by n sub 2. You add those two together, and then you take the square root of it, and you get this right here. And when you do all that, you get a t of 4.694225, 4.69. And when we look at this, by the way, Excel and other programs can actually do this for you automatically. You will see that this is exactly what we got. Sorry, not that one, this one right here. This one right here. There's our pooled variance. Okay, that we calculated 1.383117, just to check it, make sure that we have the right thing. Okay, there it is, 1.383117. Okay, and that was used then to get this t-statistic, 4.694225, and we got 4.694225. That's exactly what we want. Now, now that we've looked and found the correct t-statistic, we now need to figure out whether we should reject or fail to reject the null hypothesis. So you remember, degrees of freedom for a two-sample t-test is n sub 1 plus n sub 2 minus 2. Now the reason why I kept it that way instead of just saying big N minus 2, right? The reason why I said that is because we used it when we calculated pooled variance. So that's why. It's really just everybody minus 2. That's what we're actually saying. In this particular case, we need to find out whether we should reject or fail to reject the null hypothesis for our hypothesis about cat and dog people. Remember, the hypothesis is I think that cat people drink more tea than dog people do. So sub 1, that's cat people. Sub 2, that's dog people. And we had a total of 13 people. We had 6 cat people. We had 7 dog people. 6 plus 7 is 13 minus 2 is 11. So the degrees of freedom is going to be 11. Could I reject or fail to reject the null hypothesis? To do this, we remember what we were looking at before. So the t that we calculated is 4.69. So 4.69, and our degrees of freedom is going to be 11. So 4.69 with degrees of freedom is 11. Let's go ahead and look at our table. Let's look at a two-tailed test with alpha equals 0.05. Remember, our degrees of freedom is 11. Let's go ahead and mark where that's going to be. So here's our degrees of freedom, 11, right there. And we're looking in this column because we want a two-tailed test with alpha equals 0.05. That means that our critical value is 2.201. 2.201 is right there. The statistic that we calculated, however, was 4.69. 4.69. So 4.69, that's way more extreme than 2.2. That's way over here. That's way over here. That means we can reject the null hypothesis. Thanks, everybody.